Okay, so let us start. It is already 7:02. Let us wait for a few minutes, then we will start. 1 2 minutes. Let us wait for 2 minutes. I've got an exam coming on 19th, so I would spend a little. I won't extend this session long. I will keep it short, so I won't be giving you much time. Try to solve it within 3 minutes time that I'm giving you. Okay. So the session may be of about half an hour or so. Uh, so within that half an hour, I will give you 3 minutes to solve each question. Try to solve those questions in that 3 minute time, because after that I will show you the solutions. Okay, so today's session will be short. It will be around maybe half an hour or so, and then so try to solve it as fast as possible. Okay, so let us start with the first question. Again, very simple question I will start with. Okay, so this is the question. The system has been given to you. So as a block diagram has been given to you, and you need to find out the similar transfer function. It's a very similar sum which you have been doing for a long time. Try to do it as fast as possible. Tell me the answer. So I will give you 3 minutes time. It is 7:04. So 7:07 I would be asking you for the answer.
Zero point two, sir.
0.2.
Two.
Okay. That is Anubhav. Was that Anubhav? Who was that?
Abhishek.
Okay.
For one.
Okay. Now Kirti, what is the status? What are you getting now, Kirti? What is your answer?
Sir, I'm doing.
Okay.
Sir, sorry, sir. 1 by 3, sir.
Yes, who was that?
Abhishek.
Abhishek, yes.
1 by 3, sir.
1 by 3 you are saying, okay. Anubhav said is 1. Now Skitki, I haven't got any answer yet. It is already time. It is, I've given you more 1 minute extra actually. So what I will do is, okay. So let us go for the solution. So it shouldn't take that much of a time. We have done this quite many times actually. So same thing. You convert this into a signal flow graph. Okay. So the signal flow graph would be in the fashion which is shown in the slide. So you mark the points. How many points you have? 1, 2, 3, 4, 5. So those points you have to mark over here. Connect this by a gain 1 if there is no gain in that path. If there is a gain in the path, put that gain in that in that arrow, over that arrow, and construct the signal flow graph. That is the only thing that you have to do. After that, everything is known to you. We have one loop over here. This loop has a gain -2 because these are negative feedback, minus the C over here. So loop gain is -2. What is the forward gain? So 1 into 2 into 1, that is 2, and then there is another forward path, that is 1 into 1. So G2 equal to 1. So again this term delta, which I have explained almost a million times now, which is given by 1 minus sum of individual loops plus sum of all possible gain products of two non-touching loops. So there is no non-touching loop over here. So forget about all other terms, only first two term will be there. So 1 minus L1, that becomes 3 because L1 was -2. Again delta 2 and delta 1 and all the uh, as the loops are all touching both the forward path, so again all other terms would go to 0. You are left only with the first two terms and you would get delta 2 equal to 1. Having said that, use that Mason's gain formula, you will get the answer is 1. So Anubhav was right. The answer, correct answer is 1. Abhishek, why did you get a wrong answer? This signal flow graph
Uh,
I have solved millions of times.
yes, sir. मैंने नेगेटिव साइन ले लिया था. सिंबल नहीं ले.
Don't commit mistakes in these sums which are very trivial, because signal flow graph, if it appears in your paper, it is a scoring thing. It is something that you are given so that you can score. So if you do mistake over there, then it is a problem.
And
So
sir,
the
I
next
by mistake took feedback as one instead of two.
yes, what are you saying?
So I'm saying that I took the feedback two as one. That was why I was getting a wrong answer.
Don't commit mistakes in these things. Don't commit mistakes. So this is another sum. The transfer function of HS has been given to you, which is 1 by S. The input to the system is given to you, and you are asked to find UT, that is the unit step, unit step response of the system at steady state when t tends to infinity. So impulse function has been given to you, and you are asked to find the response of this function to this input. This input is sin t divided by pi t of ut, and ut is a unit step function. Okay. So impulse function has been given to you, and you are giving xt as the input to this LTI system, and you are asked to find the steady state value of the output of the system when you are applying this input. Try to solve it within 4 minutes. I will give you. Okay, 4 minutes I am giving you. So 7:16 I would be asking you for the answer.
1 by 2, sir.
1 by 2. Anubhav, is that who was that?
Abhishek.
Abhishek.
Yes.
Okay.
1/2, sir.
1 by 2. Okay. Now, Kitty, you are waiting for you. What answer are you getting?
Sir, I'm solving Laplace function.
Okay, it's already 7:17. Okay, so I've given enough time now, Kirti. Just tell me what is your approach? How are you approaching the sum?
So y of s divided by x of s is equal to the transfer function. So transfer function is given 1 of s. So I'm taking the Laplace transform of x of t. Then after getting that transfer function, I'll take the
How
inverse
would you
Laplace.
find the Laplace transform of this x of t? How are you going to do
Yes,
it?
yes, I was taking the Laplace transform, but I forgot the term pi by t there and get everything wrong.
So now you know. Now you know there is sin t divided by pi t. Tell me how do you do it? How to find the transfer function? How to find the Laplace transform of such function? How do you do it? How would you go ahead? I mean, how would you go ahead with the sum? Sin t divided by pi t. How would you find the Laplace transform of this part? I mean, how do you find the Laplace transform of xt?
Sir, there is t, so 1 over t, Laplace transform of that s of n, it will, and then sine of t, 1 over s square plus 1, and I'm not sure about pi here.
Forget about sin t. If it is ft divided by t, how would you find the Laplace transform?
Sir, it is f of s multiplied by 1 of t, then s raised to power n.
How are you saying this, man? Huh? When there is a integration in time domain, then you have fs divided by s. There is a division in time. There is a term t in the denominator. So there has to be some integration term over here. You have to integrate in S domain. So the so the method of doing this is you first find the Laplace transform of sin t. Okay, then you integrate it from s to infinity. Okay, see, sin t you have a Laplace transform 1 divided by s square plus 1. When there is a division by t, if you take Laplace transform of that, it is integration from s to infinity of this function. I have replaced s because s is a variable over here. I have replaced it with a dummy variable u. So 1 divided by u square plus 1 to du. You perform this integration, you are going to get tan inverse of 1 by s. You can check my steps in this step. S to infinity du divided by u square plus 1. This is tan inverse of u. Okay, so from s to limits from s to infinity. So at infinity tan inverse becomes pi by 2. So pi by 2 minus tan inverse of s. So this this becomes complementary. So the complementary of tan would be cot. So cot inverse of s. So you replace it with tan. So tan inverse of 1 by s. This is what you are getting. So you have another term pi. So you multiply with 1 by pi. So the Laplace transform becomes 1 by pi tan inverse of 1 by s. Okay. Now what you have to do, you have to multiply this with hs to find the output. To find the steady state, what you will do? You will use the final value theorem. So limit s tends to 0. So see 1 by s, that this is the impulse response of the system, and this is the input that you are giving. Okay, this is the input that you are giving. You have multiplied that with s, where s is tending to 0, to find the value of yt at steady state. After doing that, you get an answer 0.5. So Abhishek and Anubhav has done it correctly. It is 0.5. Now this is the last sum. So this is the sum. Try it out and tell me what you are getting. So I am giving time up to 7:30. After that I will ask you what you have got.
Option C, sir.
How many?
Option C, 2, sir.
Option C.
2. Yes, sir. Closest to right side.
C, sir.
C. How are you doing it?
Route criteria.
ये सर उस वहाँ पर मेरा साइन चीज 2 होता है सर, मीन्स वहाँ पर मेरा कोड 2 होगा। फिर सेकंड डायग्राम में देखेंगे कि अगर के का वैल्यू लेस देन 1 होगा तो फिर मेरा जो इंसर्मेंट होगा वो 0 होगा सर। और
I am not able
उसके
to
बाद
hear what you are saying, Abhishek. Abhishek, what are you saying? Please be a bit loud.
सर सबसे पहले राउट क्राइटेरिया से हम लोग नंबर ऑफ साइंस चेंज देखे थे, ये कितना साइंस चेंज हुआ है, तो वहाँ पर मुझे 2 साइंस चेंज हुआ।
अच्छा.
और फिर वहाँ से मुझे मालूम चल गया कितना साइन बना, उतना मेरा कोड जो है राइट साइड में है। फिर उसके बाद सेकंड डायग्राम में देखें कि के का वैल्यू 1 से जब छोटा है तो कोई इंसर्मेंट नहीं हो रहा है। इसका मीन्स इंसर्मेंट नहीं होगा, मीन्स एन 0 होगा सर। और एन इज इक्वल टू पी माइनस जेड, और पी मेरा 2 है सर, तो जेड का वैल्यू यहाँ से 2 होगा, तो ऑप्शन सी।
No. क्या 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 बोले, फिर से बताओ। ये तुम राउट क्राइटेरिया से क्या निकाल रहे हो?
सबसे पहले देखिए कितना साइन चेंज होगा सर, ये
So what are your
राइट
meaning
साइड
of
में
number of sign changes?
2।
No. What
2
is
सर,
that? What is two?
2 is the poles open sir.
Open loop poles you are saying. From route, how do you route
In
array you are
the
getting open loop poles.
in the right hand side.
So from route array you get information about the open loop poles. That is what you are saying.
नो सर, मीन्स जितना मेरा साइन चेंज होगा उतना मेरा राइट साइड में पोल्स होंगे।
किसका पोल होगा? ओपन लूप पोल होगा कि क्लोज लूप पोल होगा?
ओपन
हाँ,
ओपन
ओपन लूप पोल्स होगा। अनुभव, whatever whatever he is saying, is he correct or is he wrong?
Close loop follow.
Yes.
Close loop follow. 1 plus ds
Right,
is
right, yes.
characteristic.
From the route
Yes.
criteria, you will get the number of
Yes,
closed
sir.
loop poles, not the open loop poles.
Yes, sir.
Okay. So basically, if we use route criteria, there is no need for all this Nyquist plot at all. Okay, there is no need for Nyquist plot in this question. If you are using route criteria, that is a smart way of using, because for using the Nyquist criteria, you need two information: the number of open loop poles and number of closed loop poles you have to find out. So you need two information: one, number of encirclements that you have, and number of open loop poles that you have. Now it is a you know there are is a cubic equation, and there is one term also missing. It is difficult to find out solutions to this cubic equation unless and until you have a calculator. So if you don't have a calculator, the only way out that you have is you should use the route criteria. So I will show you two ways of doing it, as already been pointed out. So you see where k has been told to vary from 0 to 1, so it is not exceeding this point, and k has already been told, k is already been told over here. Okay, k is between 0 to 1. Okay, so it is never intersecting that critical point. Okay, because k, maximum value of k has been told to be 1, so it will be at this point. It can never cross beyond this. Okay. So number of encirclements of the critical point is 0. The open loop poles, if you solve this cubic equation, you will get these are the 3 poles that it has. Okay, so on the right hand side you have basically 2 poles. You see, these are positive real part. So these 2 poles are lying on the right hand side of the S plane. So from this information you can now use the route criteria, Nyquist stability criteria, and you can find z equal to 2. Correct option is C. And the other way out is to use this, so you have to use some value of k. So you use some value of k between 0 to 1, say k equal to 0.5, and you will be able to get this route table, and you will see that there are 2 sign changes, and hence there are 2 closed loop poles in the right hand side of the S plane. So this is another way out. This actually in GATE exam, this is the only way out, because it is difficult to for you to find that when there are complex conjugate poles, you won't be able to find it easily from this equation. So it is better to use the route criteria rather than using Nyquist stability criteria for solving the sum. Now Kirti, have you got it?
No, so I was trying to get the answer using Nyquist plot, so no.
Did you understand how this can be done without using Nyquist plot?
Yes, sir, I got it.
Okay, so keep these things in mind while solving the question. You cannot be, the question is such that it will deviate you. I mean, the question that you just saw, it is going to deviate your mind. You will think of Nyquist plot and all those things. You will be trying to solve the cubic equation, and then you will waste a lot of time. So you have to keep your mind open. So what alternative do I have? That you have to do. That you have to develop by practicing. Okay, by practicing, by understanding from each and every sum that you practice. Only practicing is not enough. You have to, what are you learning from the sum that you have practiced, that is important. So you have to keep that in mind. Anyways, so today I will stop the session here, because I also have to prepare for some examination. So I will end this today, and maybe I have given you an assignment of drawing the flux lines of the DC machine. I have not forgotten it. I will ask you to do. I will see your answers in the next week once my exam is over. So keep that ready. Okay, I will ask you to share your screen, and I will ask questions on it. That will be on the next week. So you will have your time till then. Try and study hard. Okay, then today I'm going to stop over here. Okay, have a nice weekend. Enjoy your weekend. Thank you.
Thank you.